This becomes what's called an abstract syntax tree. So what we're doing now is we're representing parts of some source code in a new language as constructs in the language of the compiler. We're writing a compiler in JavaScript, and so the important parts of our source language are now represented as arrays in JavaScript, and we can work with them with all the power that we have with JavaScript arrays. So we can filter and we can map and we can do replacements. They're constructs in the compiler's language, in this case, JavaScript. It might be even more useful for us, instead of creating an array of a definition construct, to make a definition class and to assign some values to that. This way, we can put logic about the definition, so validation about it, and interesting things that it does, like actually parsing, we can put those inside an instance of this class and not fill up our parser with that stuff. So, a small addition that we can make to our parser class, or to our parser JS bin window, is to make a class for definition. And you could make multiple of these classes for different constructs in your language, like if statements or whatever, loops, that kind of thing. We'll just give this a constructor. The things that we're interested in for definitions are the type of the variable, the identity of the variable or the variable's name, and its value. We can give that a default of null. And I've just introduced a horrible thing into my language, because now it supports null. But basically, we just want to store these things. So this type is type, identity is identity, and this value is value. Okay, so we've got a class. We've given it a constructor, which means when we say new definition, we can actually pass those values into it. And then we can start to add interesting logic inside this class as pertains to the definition construct of our language. We can include this by adding some more logic here in the parser to say, if the type of this token is definition, oof, the spelling is intense. If the type of this token is a definition, then we actually want to replace it. Starting where it is, we're just replacing one thing, and what we're replacing is an instance of the definition. And awesomely for ES6, we can use the spread operator here to expand the properties of this array as if they were individual parameters to this constructor. Yay for ES6. Okay, now because we've got two kinds of tokens we can manage in this parser now, when we have a match, we actually need to reset the count. So the parser can start right back at the beginning of the tokens. This is useful for if we have individual constructs that can form part of a larger construct. Think of mathematical operations. You can have 1 + 2 × 3. You want to isolate one construct there, like the times, create a kind of arithmetic operation construct from that, and then use that as the right argument to another larger arithmetical construct, 1 plus the result of that times operation. So when we match a token, let's go back to the beginning of the tokens array and just start again and make sure that we're combining everything together. Because we've got a match here, we'll do the same. Tokens.splice. Okay. So we've basically just added some new logic to our parser to pull out arrays that start with definition and replace them with instances of the definition object. Are there questions about this syntax at all? Okay, let's look what this gives us. Yay, object, identity type value. Now, this console, it's not immediately apparent what that is, but we can do console log result and also result 0 constructor name, just to make really sure that it's an instance of a class. And here we can see, okay, it's an object with these properties. It is a definition class. Yay for replacements. Everyone here? Everyone happy with this? Any questions? I'm going to move on. Oh, yeah, sure. Is it making sense? Sweet. Okay. Now, from this point, we can do one of two things. We can make an interpreter which will evaluate this code immediately, taking some input context and giving us a new, potentially, output context. Okay? That's what I would loosely refer to as an interpreter. Alternatively, we can make a compiler or a cross-compiler. Say, for instance, we were making this compiler, but we wanted a new language to be translated to Ruby, and for some bizarre reason, we're using JavaScript to make the compiler. Well, instead of applying the different abstract syntax tree elements to an input and output context, we can take the abstract syntax tree that we have and rewrite it in a new language, like Ruby, for instance. We could take some source code that is of our own making and convert it to working source code in another language. And so for that reason, we would make a compiler or call it a cross-compiler. What I'm going to focus a bit on is making an interpreter, so something that evaluates the result of some code immediately. Okay? It calculates this immediately. And my interpreter is always going to accept a starting context, the same as if you provide input parameters to a script when you run it from the command line. And it's going to return to me a resulting context. So something that has meaning for me. Maybe I can see how the internals have changed some global variables from one value to another value. What I want to do is I want to go through each of the objects that I've defined in my source code that have been made into constructs of my language, and I want to apply them to a starting context, kind of like this. So I'm going to write some code for that. Yay! Okay. Again, I'm going to open up a new window, but this one's even simpler to do now. Just copy your definition class.
You have a question?
Yes. Oh, yes.
Yeah, when do you want to do the type checking?
You can do it here. You can do it in the interpreter. I'll show you in the interpreter because that's what I plan to do. So that's a very good question. You can do type checking here in the first place, but it's probably nicer while we're still getting to grips with stuff about compilers to isolate the type checking logic inside the definition class in this language. So copy that class that you defined up there and put it in a new JS bin window. Yay! I'm going to make it do JavaScript, ES6, and I'll paste that class there. And I'll get the console app, all these things. Right. So we have a definition class here. Up to this point, we've defined code that says int minutes is 90. And so what I want to do now is I want to simulate this as it will look when it's gone through the lexer and been split into tokens, and then through the parser and been arranged in constructs of a language. So I'll say that I have an objects array, and it's just got a single thing in here. It's got a new definition of type int, variable name minutes, value 90. Now we can make this more interesting and imagine we had something like int hours is 0. And so what this objects array would look like at that point is that there would be an hours thing here with a value of 0. Does that make sense? By the time it's gone through the lexer and the parser, that's the kind of thing we're expecting to be working with. Yes? And now because I'm making an interpreter, the way that I'm going to use it is to say let an instance of oh my gosh, interpreter is a new interpreter. And the result of this, my spelling is terrible under pressure. Interpreter, analyze. Okay, so a very similar thing that we've done so far. The way that we want to use this interpreter is to create a new instance of it and run a list of objects that we have at this point through it so that it can do something meaningful with them. Let's define what that looks like. This has an analyze method, and it takes in some objects, an array of them. So we'll give it a default. And this one is super simple. Oh, by the way, this also takes in a context. I'll demonstrate how to use that in a little bit. This one is super, super simple. We loop through all the objects that we have. In this case, it's just definitions. In your language, if you go more complex than this, you can have if statement objects, you can have while loop objects, you can go crazy. We loop through each of those, and for each one, we modify the context. We set a rule that every object definition's a confusing word in this context, but every construct of our language has to have this apply to function. And it's got to take in a context, and it's got to return a modified context, if that's what it does. It's got to return something, right? And so we go through every object that's defined in the source code we're parsing, and we call that function, and the result of that is what context then becomes. It's a kind of top-down evaluation model. And right at the end, we return the modified context. Okay. In order to fulfill this contract that I've started off, I heard a question coming, and I'll answer it right now. I just want to make this apply to thing that takes in a context, which is an object, and returns that context. So when we run this, it's just going to do an empty object. There was a question coming. Oh, okay, sweet. All right, now this doesn't do anything meaningful, but it's good groundwork to start really doing interesting things here. For instance, in the supply to method, we can start to do some validation. So some type checking validation, some validation. So what we can say, for example, is if this variable's already been defined, then we can throw a new error. Okay. So how can this work? Well, if we give our application some default context, something like minutes is 5. Something like this, for example, input parameters for our program, then this will actually trigger. Minutes is defined. There's some validation that we've started doing. So if a rule of our language is you can only define a variable once with type name equals value, well, here's where we can put that validation. We can do some type checking as well. We can say, if this type is int, and this value match that, then it should be a valid value for this type. If not, we can throw a new error. Cannot be this value. Okay. And we can actually see this working if we go down to our initial definitions and just change this to true. So we want to define an integer variable with a value of true. What will this look like if we run it? Yay! Minutes is defined. Let's remove this initial context again. Minutes cannot be true. So that's where you can start to do type checking as well. Does that make sense? It's a good place, right? You can start to enforce little rules about each construct in your language, and this is a good place to do that. Of course, if it's the right value for this type, we can just apply this to the context. And we probably also want to parse this so that it's internally stored consistently. So the value and the radix of 10. When we run this, minutes cannot be that type. Now we have a resulting context that has these variables defined to it. We started with blank, we ran our program, and we got some significant resulting values. If you connect these all together in one JS bin or one JavaScript file and you run them, your lexer, your parser, your interpreter, you would have gone from a string that says int minutes 90 to an object that is now affected by code in the parser that you just wrote, in the compiler that you just wrote, which I think is awesome. I mean, that's basically a compiler that we've done. Admittedly, very basic syntax to begin with, but significant nonetheless. Are you happy with this? Are there questions about the interpreter? More questions than have been asked. I love it. Ask if there are. Yeah, sure. Any questions? Everyone happy with this? Fulfilled as people? Wish I had one of those Minority Report screens and I could just go like, and have like a static version of that like next to it. That'd be rad. Okay, can I carry on? Yes? I see lots of nods. Now, if you wanted to make this into a compiler, what you would have to do is you would have to take those arrays of definitions or instances of your objects, and instead of a method like apply to affect a global scope, you would have another method which would write the internals of that object in another language. If you were going from custom language to Python, you would have a definition class method that says write to or whatever, and it would return a string of Python code. Okay? It's a good place to check for the constructs of your language and how they apply to the target language. To give you an example of this, who's heard of TypeScript? Okay, quite a few of you. It's a strongly typed JavaScript superset language by Microsoft. And it's kind of cool. But what I imagine happened was that some developers at Microsoft thought, you know, we're doing a lot of type checking in our code. It's making a lot of boilerplate. It's harming our productivity. What we actually want to do is we want to have a new language with strong types and the rest of JavaScript. We want to have some special syntax. And so what they invariably did was make a compiler that compiles this JavaScript-like language to JavaScript so that you can use it for your normal stuff. along with some syntax checkers and type checkers that a strongly typed language benefits from. There was a point at which they probably got to some type code and they needed to convert it to JavaScript, regular JavaScript, and they have a type definition, a variable, and a value that they're assigning. And so JavaScript doesn't have strong types. I'm not sure what the TypeScript stuff compiles to these days, but I imagine at that point they could say, okay, JavaScript doesn't support strong types. Let's add some assertion code around this, or let's just ignore the type definition altogether and have the type checker tell them if it's wrong before it compiles. So if you're making a compiler from one language to another, this is a good place to iron out those inconsistencies between languages. To recap all the things we've done, we started with some source code. Int minutes is 90. And we decided some rules about how our language looks, what the grammar is of the language. We've got type definitions, identities, assignment, values. Alternatively, someone can just say type variable name, and that's enough for a statement. So we took some source code, we created some grammar. We put that grammar to work. We took some source code and we tokenized it, split it into significant tokens of our target language. We then arranged these in a kind of structure, a hierarchy, and even created objects based on classes that we could use to validate. Finally, we took those objects and we applied them to a starting context and got a resulting context. If you're doing this stuff, you can do other interesting things like write to standard out or modify files or connect to third-party APIs. You don't just have to take an input context and give an output context. But this is helpful to know if you're doing things like having global scope in your programming language. And we got a compiler. That's awesome. I think that's awesome. Now, before I go, in the last few minutes that we have, I want to look at compiler generators. And the specific DSL that I want to look at is Parser Expression Grammar. You can go to a website called pegjs.org. And it looks like this. In fact, if you took a plane to get here and you're taking a plane to go home, you can actually go to GitHub, pegjs. I wonder if the GitHub search will return the thing I'm looking for. Hard to tell. Yes, it does. Okay. You can actually go here and you can clone this repository and run it on your local system. And what you'll get is the live REPL that this has. Yay! And all of the documentation that this has for how their grammar works. So you can play with this without an internet connection and really create compilers from this. That's pretty rad. Now, most of these compiler generators have some things in common. They use pattern matching in a custom DSL, and then they create code that goes through the same steps we've just done. Code that creates tokens, code that organizes these tokens in a hierarchy. They write this code, and then they generate a reusable interpreter or a compiler. If you go to pegjs, you can actually specify the global variable or the way that the compiler you make with it outputs. So they give you this generated compiler, like the one that we built, and then you can include it in your other projects to parse your custom language, your custom code. I actually have samples of what this looks like. So I've implemented the language we've just done, plus a separate construct in the language. And I'll show it on slides, actually, because the size is much better. In pegjs, you can define some global JavaScript stuff that your language will use to work itself out. I've said, OK, I've got a starting context, which is blank, and I've got these two helper methods to set and to get values from that context. Then I've said, right at the beginning, right at the start of my compilation step, the language that I have is any number of expressions, or no expressions, which is what the star symbol means. And that each expression can be some optional whitespace, a definition, and some optional whitespace, or some optional whitespace, an inspection, and some optional whitespace. Again, whitespace just being defined as space characters, tabs, carriage returns, new lines, 0 or more times. Again, that's what the star means. So I can have a trimmed definition statement, or I can have a definition statement sitting between 50 new lines.
That definition of white space means between every character is white space. So you have A, nothing, B with a white space in between. Don't you want plus there? Because zero, a white space with zero of those things is between every character, and you'd have infinite white space.
You're right, you're right. Actually, it would be much better to use a plus there than 0 or more. That's actually a very good point. That's probably why this was slowing down a lot. Anyway, it also explains some syntax you're about to see in a bit. So, wow, I didn't think of it like that. That's a very good point. Every definition of our language matches a similar grammar to what we had before. So a definition can be a type, white space, a variable name, white space, equal symbol, white space, value, white space. You get the point. And every time PEG.js sees this kind of expression, it's got to use that global setter that I used to add some data to the global context. I'm not adding type data in here as a bit of an oversight. But if you wanted to add type data along with a value, you could just set with an array of value and type. Now, it can either be that full assignment for definitions, or it can just be type and variable name. And then each component of this pattern can be expressed like this. So all the available types in this language are just int. Every variable identity is a collection of letters joined together. And the reason I'm joining them together is because I did the star for white space. And if you didn't do that, you wouldn't have to do this. But it makes sense now. I'll actually try that now and see. So assignment is equal, value is any numeric characters joined together and passed as an int. And terminal is just semicolon, if your language supports it. The thing that I added to this was inspect. So I wanted to console log stuff to see what was going on, and you can do that with adding this to the language. Oh, before we get there. All of this code together looks like this. Yay. Unfortunately, I can't resize this any wider, and the contrast is terrible. But I just actually want to replace this star with a plus. After that awesome suggestion, and see if this actually still works. Oh, that doesn't work. Okay, I'll figure out why that's broken in a little bit. Anyway, what this has done is it's allowed me to define the grammar of this language on the left-hand side here, as with the slides you've just seen, and then some input source code. So int minutes is 45, inspect minutes. And if I go to console, my inspect command is actually going to console log this. So int minutes is 45. I'll change this to 50. And the moment I change that, it'll run this source code through the parser. And the result down here is printed because I have inspect minutes. Now, we could have saved ourselves an hour if we just started with this. But I hope you see that starting at this point means we don't know at all how the compiler is actually working underneath. Now that we went the long way and we made the lexer and we made the parser and we made the interpreter, we can expand on those to create interesting languages and to pass interesting DSLs that will help our business logic. And I don't think we would have had that learning if we'd started with compiler generators to begin with. That is all I have for you. Before I take questions, if you go to that link, you can give feedback on the session to tell me what I did wrong, and I'd really love that feedback so I can be better next time. And I'll also post links to all the source code and the slides there. Alternatively, if you don't want to leave feedback there, I won't hold it against you, but you could also follow me on Twitter, and I'll post links to the slides and the code there as well. Also, I'm giving a talk tomorrow on programming in Minecraft, which is going to be a lot of fun, and hopefully this workshop hasn't put you off that. Are there any final questions? Yes?
Well, at the beginning you spoke about their general utility. Have you actually found opportunities in
Yeah, so in the work on Silverstripe, I haven't written it. My CTO actually wrote a template engine for this, and the template code is terrible. I don't like it at all. But it was using a version of Peg.js grammar implemented in PHP. So in that case, yes, there's a custom compiler written with grammar rules to compile template code to normal PHP code. I did a similar template engine ages and ages and ages ago before I understood that it was actually a compiler according to these definitions, basically just because I ported it from another language. But other than that, I haven't found many uses. I think generally the work that we do in PHP is very well defined in terms of the tools we have. An interesting application of this that I have seen recently, though, is that a lot of behavior-driven development testing frameworks, like Behat or Gherkin or Cucumber or whatever language you're using it in, are written with a custom DSL. So they're written very idiomatically. You can say, as a user, when I click X, I see Y. And so that's a DSL that's implemented through techniques like this as a very good use case. That's a good question. Thank you. Any other questions? Yes?
So you said you took one and we didn't course another one. So as a good practice for this, would you recommend us doing the same? Taking one language and then trying to implement maybe another language?
I think trying to get a whole spec compliant language compiled to another one is a very intense task to take on.
Maybe not as far as the whole thing, but just like you did.
Yes, yes. Yeah, exactly. So starting off with small bits of the language, it is a good idea because then you can, if you read the spec for those parts that you want to implement, you can get a better understanding of them, and it's a good way to learn this stuff. So yeah, that's a good statement. If you want to get into this, you can take one language and compile parts of it to another as a good way to learn. Any other questions, comments? We still have 5 minutes, I think. Yes, exactly 5 minutes. Okay, so what I'm going to do is I'm going to go back to the...
What is the link to the code and the slides? I'm on that link that you sent before, but...
Oh, this, you're on this link over here?
Yeah.
So I haven't uploaded this code yet. I'll put a link there. Okay, maybe I have enough time and perhaps enough energy to try and implement my inspect statement in here. So I'll just do it like this, similar to the type definition. I have to put it above entity because otherwise it's going to be picked up as a variable name. But let's do that there. Now when we run this, we should have, and we also have to do semicolons to differentiate symbols. So terminal, and this is a semicolon. Yay. So now I should be able to say inspect minutes. And hopefully that tokenizes. Yes, it does. Okay, so now I have an inspect token. Oh, my window manager. And I have a terminal token. Okay, so what I would do is I would take these tokens over to my parser. Yay for all of this. Over to my parser. And then I'd say, let's see, class inspection. It doesn't actually need a constructor because I don't have any significant values in there, but we'll see how this is used in a little bit. Okay, so inspection class, if tokens I is of a type inspection. Okay. I'm just going to remove this part here. Yay. And run. So I have some tokens here that I don't really know what's going on. Okay, what tokens do I have as a result of this? Int minutes. Okay, so when I get to my parser, I actually do care about tokens on the sides of this inspection. I'll just go straight to, I won't create the definition array, but I'll just go straight to tokens I plus 1. Because if I have an inspect statement, the token just after it is going to be the variable that I want to inspect, so I can kind of make that assumption. But I'm lacking some validation here, right? So just be aware of that. And actually, I only care about the value. I don't care about the type of that. So if I have constructor, it'll take an input of that. Oh, and also I should probably splice with this with a length of 2, because I'm removing 2 tokens and replacing it with 1 entity. Okay, so I've got a definition object. I have a terminal, which I'll strip in the interpreter, and then I have an inspection object, which has the variable that I'm inspecting, right? If I take this over to the interpreter as my starting stuff, essentially what I will have, if I care about it, is that I will have a definition, minutes 90, and I'll have an inspection just for minutes, something like that, right? Does that make sense? And if I copy my inspect class back over, just having like a brain dump. I'm not actually cognizant right now. Anyway, all of these things, all of these objects, constructs of my language need to have an apply to in them. I'm not actually going to modify the context at all. I'm just going to console log context this identity, because that's what my inspection construct needs to do. And then if I run this, 90. Yay. So you can see how even though you start off on a simple language or just little bits of a language, you can build it up and build it up in the way that I've just built up the stuff that we've done here to add a new construct to the language. It's a very good starting point and is probably terrible for your sleep, the amount of sleep you'll get after knowing this stuff, but still pretty awesome to do. Any closing questions? We're a minute over. If you have any and you're just a little shy like I am, by all means catch me at the conference and ask me then, or check out those links or my Twitter to get the slides and the source code. Thank you very much.